In the previous example, we just treated fractions like they were any sort of other number and used the straight principles for solving an equation to find a solution. Now I want to see if we can figure out a little bit more efficient way of looking at an equation with fractions to make our job just a little bit easier. So in this example, it's 1/4 n plus 2/5 n minus 1/2 equals -9/10. So in this one, what I want to do first is to go ahead and get a common denominator for all of these fractions, and then put the equation in terms of equivalent fractions, all with a common denominator. So I'm going to actually keep this separate, even though you could choose to draw this or write this kind of linearly. So I'm going to look at our denominators. So the denominators are 4, 5, 2, and 10. And if I write out their prime factorization, well, 2 and 5 are prime. So their prime factorization is just the number itself. 4 is 2 times 2. And 10 is 2 times 5. So the LCD of these four fractions would be the LCM, or whatever, however you want to look at it, of these four numbers. So remember, I'm taking the highest occurrence of each of the prime factors. So the prime factors are 2 and 5, and 2 occurs at most twice in the factorization of 4. It occurs once in the factorization of 2 and once in the factorization of 10, but it occurs most in the factorization of 4, where it's 2 times 2. The other factor that occurs is 5, and it occurs once in both 5 and 10. So we write it down once. So that means that our common factor here, or our common multiple, our least common multiple or least common denominator, is 2 times 2 times 5, which is 20. Okay, so then just to make my life a little bit easier, I can go ahead and write down the multiples, or the numbers that I need to multiply by, because I want to make sure that I get 20 on the denominator of each fraction. So all I'm doing here is trying to figure out, what do I multiply by? Well, 4 times 5 would give me 20. 5, I need to multiply by 4. 2 times 10, and then 10 times 2. So then coming back over to my fraction, I've got all the pieces that I need to convert this over to equivalent fractions with a common denominator. All right, so 1/4, I need to multiply by 5. I need to multiply the 5 by 4 to get to 20. And if I'm multiplying the bottom, I also need to multiply the top. And then this n, I can just leave him hanging out in the back. 2/5, I need to multiply 5 by 4. So I put a 4 on bottom and then also a 4 on top. And I do need to remember to have the n hanging out in the back there. Minus 1/2. Well, I said I needed to multiply 2 by 10. So 10/10 is what I'll need to multiply there. And then -9/10, I said I need to multiply the 10 by 2. And so if I multiply the 10 by 2, I also need to multiply the 9 by 2. Now this looks a little messy, but we'll clean it up in just a second, and hopefully you'll see that it is a little bit simpler for us to work with. So I know that my fraction is going to end up with 20 as the denominator. So I can go ahead and write these down as having 20 in the denominator. But if you want, and it's a good practice, to go ahead and check, 4 times 5 is 20. And then for the numerator, it's going to be 1 times 5. So that'll be 5/20 in, plus, all right, 5 times 4 is 20, and then 2 times 4 is 8. So it'll be 8/20 in, minus 2 times 10 is 20, and 1 times 10 is 10. So it'll be minus 10/20. and that's equal to a negative. All right, 10 times 2 is 10. 9 times 2 is 18. So negative 18/20. Okay, now that I've got a fraction that all has the same, or all equation with fractions that all have the same denominator, I don't have to worry about switching up denominators or doing anything else. I can just solve the equation as it sits. Okay, so it says apply the distributive property, remove parentheses. That's step one. We've done that. Now, combine like terms on each side of the equation. Well, I do have two terms within, and so I can combine those into a single fraction. Since the fraction has the same denominator, I can just carry the denominator over and add the numerators. 5 plus 8 is 13. So 13 over 20n minus 10 over 20 equals negative 18 over 20. Now then, looking for constant that is added or subtracted from the variable. In this case, it's minus 10/20. And again, I want to do the opposite operation. So right now, negative 10/20, that's subtraction. So if I wanted to do the opposite operation of that, I would add 10 over 20. Now, I can't do that to just the left side. I have to do it to both sides. So the negative 18 over 20 is going to have plus 10/20 as well. Now then, I can go back and simplify this sum. Remember, negative 10/20 plus 10/20, that's 0. So on the left-hand side, I just have 13 over 20n. On the right-hand side, negative 18 plus 10 is negative, but now it's 8 over 20. Okay, and the last step is to divide by the coefficient. Okay, so before, in our previous example, we went through the process of saying, okay, we have 13 over 20, and I'm going to divide by that same coefficient, 13 over 20. But what we ended up doing was rewriting this as 13 over 20 with a division symbol, 13 over 20. And then we said, well, when you get to dividing fractions, really what you're saying is it's 13 over 20 times the reciprocal of the fraction. So it ended up being times 20 over 13. And that just ends up equaling 1. But I want us to look at this part. Instead of always writing a complex fraction and saying, okay, I'm going to divide by the coefficient, and the coefficient is 13 over 20. I want us to think about it in this term. If I'm going to go through this whole process of starting with a complex fraction and then simplifying it down to a division problem, and then switching this to a multiplication problem ultimately, then I could just save myself the trouble and saying, okay, I see where this pattern goes. What I'm going to end up doing is multiplying this by the reciprocal. So I'm just skipping ahead and saying, ultimately, this is what we're doing. So I'm just going to go ahead and do that. You can, if it helps, always write it out the long way. But when you get to a certain point, you go, okay, I'm tired of writing the same thing out every time. Can't I just go ahead and multiply by the reciprocal? Well, yeah, you can, because that is, in effect, what we are doing. Okay, so now knowing that, we can see that, well, the 20s and the 13s cancel. And we knew that because we multiplied by the reciprocal specifically so that the fraction in front of n would cancel. The other thing that we see here is, well, the 20 on the right-hand side, those 20s cancel as well. And really what they do is they factor out to just be 20 times 1 and 20 times 1, and the 20s cancel and they leave a 1. So then we can multiply the fractions straight across. 8 times 1 is 8. And then 1 times 13 is 13. And we need to remember that we had a negative sign here that I need to bring down. So it's actually going to end up being negative 8 over 13. So still a lot of math, a lot of places for error, but it's a little bit better than trying to treat these as separate fractions and then finding common denominators between two of them each step along the way. So hopefully that's a little bit cleaner than our previous example.